In lesson 07, we're going to be working with calculating the probabilities. And in order to calculate probabilities, you're going to have to find the possible number of outcomes of an experiment. And within that context, you may use the idea of permutations and combinations to calculate probabilities. So we have two basic objectives: is to find the number of possible outcomes of an experiment, and the second one is to use permutations and combinations when appropriate to find probability. So some basic background information here. They have a sample space. An experiment is a situation involving a chance or probability that leads to specific outcomes. The set of all these possible outcomes is called the sample space. One method that can be used to determine the number of possible outcomes of an experiment is a fundamental counting principle. So in our key concept, the fundamental counting principle tells us we can figure how to calculate how many outcomes there are in any given experiment. And it says let A and B be two events. If an event A has n sub 1 possible outcomes and is followed by event B that has n sub 2 possible outcomes, the event A followed by event B has n sub 1 times n sub 2 possible outcomes. This fundamental counting principle can also be used to find the number of possible outcomes for 3 or more events. It's just that we have to multiply it by the number of ways the first event can happen times the number of ways the second event, third event, fourth event, all the way down to the kth event. A couple other things we have to look at are a couple more vocabulary words, and that is independent versus dependent events. Events with outcomes that do not affect each other are called independent, and events with outcomes that do affect each other are called dependent events. So we're going to be using our fundamental counting principle to determine how many ways we can have a situation occur. So how many possible outcomes are there? So here's our first example. A restaurant offers a dinner special in which the customer can select from one of 6 appetizers, a soup or a salad, one of 12 entrees, and one of 8 desserts. How many different dinner specials are possible? So we have a lot of different things that have to happen, a lot of different events is what they call them. I'm just going to underline some of these events. One of the events that we have to do is we have to pick from one of 6 appetizers. We also have a second event. We have to pick a soup or salad. We have a third event, and then we also have a fourth event. So what we want to do is we want to treat these as our n sub 1. N sub 1 is how many ways can the first event occur. Take it times the number of ways the second event. We have a third event, and I believe we have a fourth event. Multiply them together, it tells us how many different ways or outcomes there are possible. So there are 6 different appetizers that we can choose. There are 2 choices for our soup or salad. Our third event, we get to choose from 1 of 12, so we have 12 choices. And our fourth event is out of 8 desserts. Now, if we multiply these 4 numbers together, it'll tell us how many dinner specials are possible that we could order in any given day at this restaurant. So we'll take our 6 times 2 times 12 times 8, and it gives us 1,152 possible outcomes. So that's how many different dishes that we could possibly get, taking from their menu. Followed up with a second example. Garrett works for a bookstore. He is arranging the 5 bestsellers on a bookshelf display. If he can place the books in any order, how many different ways can Garrett arrange the books? So in this example, what we want to do is we want to make sure that we place all 5 books on a bookshelf. So think of this as the first location. That is my first event. How many ways could I have that first event occur? Then I have a second event. I have to have a second book, a third book, a fourth book, and a fifth book. So how many ways are there for this first event to happen? When I have the open shelf, I have any one of 5 books that I can put on the shelf. So I'm going to choose one of those books to go there, but I can choose from any one of those 5. Now once I've selected that book, I can't use it again, so now this is an example of dependent events. So once I've selected a book, now I only have 4 choices for that second event. Once I select a second book, now I'm down to 3 choices for my third event. Then I'm down to 2 books left, and I'm down to just my final book that has to go to that location. This tells me the number of ways that I can get these 5 books placed on the shelf. This is an example of dependent events because once I place a book, it reduces the number of books I have on my second spot for my shelf. So once I place a book, my second book number goes down, and so on and so on. So we take 20 times 6, which should be 120 different ways that we can place those 5 books on the shelf. This is an example of using the fundamental counting principle along with the independent and dependent events. I didn't allude to it at the first time, but that was an example of independent events. Once we choose our appetizer, it does not affect our choices for soup and salad. But in the Garrett's example, once you choose a book, it does affect how many choices are in your next event and so on. So independent and dependent with fundamental counting principle.